This is MHF4U1, Unit 5, page 362, number 11. This question states, the city of Thunder Bay, Ontario, has average monthly temperatures that vary between negative 14.8 degrees Celsius and 17.6 degrees Celsius. The following table gives the average monthly temperatures averaged over many years. Determine the equation of the sine function that describes the data, and use your equation to determine the times that the temperature is below 0 degrees Celsius. We've rewritten the data given to us in our own tables for convenient purposes, and each month's average temperature is represented by the day in the middle of each month. So for example, January, a month comprised of 30 days, we represented it as day number 15. Okay, a disclaimer. We are only able to acquire the theoretical equation of the sine function, basically the sine function equation that fits best. So the first step is to take the data given and graph it. We've graphed it days on the x-axis versus temperature on the y-axis. The question asks for a sine function, so we know our equation will follow the form of y equals a sine k t minus d plus c.
Now, using the given data, we can solve for the missing variables. A, which is amplitude, K, which is the period value, C, which is the horizontal axis / vertical shift, and D, which is the phase shift, which will be discussed later in detail on how to find. So, for amplitude, variable A, we use the equation max minus minimum, divided by 2, and plug in our data into the maximum and minimum values. From there, we end up with an amplitude of 16.2. For the C value, we use the horizontal axis equation, which is max plus minimum divided by 2 to solve for the variable. After plugging in our data into the equation, we get a value of 1.4. For value K, we refer back to the period equation, which is P equals 2 pi divided by K. We know that the data is measured annually, so we can let the period P be 365 days. The equation will be 365 is equal to 2 pi over K. We isolate for the K value and get K is equal to 2 pi over 365.
Calculating the value of D is different from the others. To solve for D, we would have to estimate where the horizontal axis first intersects the curve. Here in chart 1 is a regular y equals sine x graph. The horizontal axis intersects the curve at exactly 0. On our graph, though, is shifted to the right, so the horizontal axis would first meet the curve at an area approximately there. If we refer back to our first chart, that area would be between this point and this point, which is 90 and 120. In our case, though, we are going to use D equals approximately 116 because we have found it to be the closest. We have now found all the variables, and we plug it into the model equation to get T equals 16.2 sine 2 pi over 365 T minus 116 plus 1.4. And we have solved the first part of the question. To check if our answer is correct, we are going to use the graphing calculator method. Okay, so first step is to use statplot, edit, and input the data from the table into the graphing calculator. For L1, we are going to be using the number of days, 15, that's for January, 45 for February, 75 for March, and I'm going to keep going until we reach December. For L2, we are going to be inputting the temperatures. So for January, it's going to be negative 14.8, February negative 12.7, negative 5.9, 2.5, 0.7, 13.9. Okay, and once we have that in the stat plot, We press enter. We press second stat plot, and we turn this stat plot on, and make sure X is L1 and Y is L2. We adjust the window settings. Our X minimum should be 0. The max days would be approximately 390. Y min would be -20, Y max 20. And if we graph it, we get the stat plot of the data. To check if our equation fits, we press Y1 and input our equation of Y1 equals 16.2 sine 2 pi divided by 365 times x in place of t minus 116 plus 1.4, and we graph it. And as you can see, the equation fits the stat plot model.
For the second part of the question asks, determine the times that the temperature is below 0 degrees. So if you refer back to our chart, this chart. If you refer back to our chart, we know that the temperature is below 0 degrees between this range and this range, and this range and this range. So we must find the zeros of the sine function. So to do that, we let t equal 0, which is temperature, because we know that temperature is at 0 when the sine function intersects the horizontal axis. So we let temperature equal 0, and we solve for our t value, which is time, which is measured in days. So we just solve for the t value by bringing positive 1.4 over to next side, divide by 16.2, inverse of sine function, and divide by 2 pi over 365, and that will give us a value of approximately 111. Therefore, when t is between 0 and 111 days, the temperature is below 0 degrees.
To calculate for this next part, we will have to use the graphic calculator method. We'll refer back to the graph that we just made to check our work, and we could press second, calculate, 0, and we press left bound versus right bound to get the answer of 303.52654, which could be rounded to 304. So from days 304 to 365, which is the end of the year, the temperatures are under 0 degrees Celsius.
So in conclusion, our equation is t of t is equal to 16.2 sine 2 pi over 365 t minus 116 plus 1.4, and the temperature is below 0 degrees Celsius between days 0 and 111 and days 304 to 365.
Thank you. Good luck.